In the vast emptiness of space, 628 million kilometers from Earth, there orbits a small, icy moon, no bigger than our own, and yet hiding a secret so profound, it could change everything we know about life in the universe. This is Europa, one of Jupiter's many moons, and a world that, from the outside, looks silent, frozen, and unremarkable. Covered in a crust of ice, constantly bombarded by radiation, it hardly seems like a place worth watching. And yet, beneath that ice, there may be an ocean, vast, global, and alive with possibilities. And at the bottom of that ocean, hidden in absolute darkness, there may be vents, deep-sea geysers powered by internal heat, gushing minerals and warmth into the icy abyss. If those vents exist, they could be the crucible of alien life, not just microbial, but potentially complex, stable, and thriving. This isn't just science fiction anymore. It's a question scientists are seriously asking. So today, let's explore what it would mean, scientifically, biologically, even philosophically, if Europa has hydrothermal vents. Europa was first spotted by Galileo in 1610. He couldn't have known what it really was, just a speck of light near Jupiter through a primitive telescope. But fast forward 4 centuries, and we now see Europa for what it is. One of the most promising places in our solar system to find extraterrestrial life. At first glance, it looks dead, a pale, cracked world with an icy surface tens of kilometers thick. But all signs suggest that beneath this crust lies an ocean of liquid water. Not a lake, not pockets of meltwater, but a full-fledged global ocean. This isn't speculation. Magnetic field measurements taken by NASA's Galileo spacecraft in the 1990s revealed signs of an electrically conductive layer beneath the ice, something that behaves like salty water. The thickness of the ice, the surface features, even the gravitational tug of Jupiter, all point to the same conclusion. Europa has more water than Earth, maybe twice as much. And wherever we find water, especially liquid water, life as we know it becomes a possibility. But water alone isn't enough. For life to exist, you also need energy. Here on Earth, most life gets its energy from the sun through photosynthesis. But in 1977, something extraordinary was discovered at the bottom of the Pacific Ocean. A team of scientists found hydrothermal vents, cracks in the seafloor where superheated water and chemicals gush from the Earth's interior. And around those vents, life. Strange, thriving, resilient life. Massive tube worms, pale crabs, bacteria that eat sulfur. Entire ecosystems, completely independent from sunlight, powered by chemosynthesis, the process of converting chemicals into energy. These organisms live in crushing pressure, total darkness, and extreme heat. And yet, they flourish. Why is this important? Because Europa might have the same setup, an ocean in contact with rock, and enough internal heat to drive hydrothermal activity, which means it could have vents, and if it has vents, it could have life. No spacecraft has seen Europa's ocean directly. We've never drilled through the ice. We've never sent a submarine into its waters. But there are clues, growing, consistent clues, that something dynamic is happening below the surface. The first big hint comes from the way Europa's surface is shaped. It's crisscrossed with fractures, ridges, and chaotic terrain, as if the ice is being broken and refrozen by some underlying force. Scientists believe this is due to tidal heating. The gravitational push and pull from Jupiter flexes Europa's interior, generating frictional heat. This heat might be enough not only to keep the ocean liquid, but also to create hot spots at the ocean floor, where rock and water interact. just like on Earth. Then there's the plume evidence. In 2012, and again in later years, the Hubble Space Telescope spotted what appeared to be jets of water vapor erupting from Europa's surface, possibly from the ocean below, breaking through cracks in the ice. If confirmed, these plumes could carry chemical signatures of hydrothermal activity from the seafloor to space. Imagine that. Vents spewing mineral-rich water from the bottom of Europa's ocean, some of it shooting up through the ice, out into the vacuum of space. A deep-sea vent system, launching clues into the sky. If Europa does have hydrothermal vents, and if life exists near them, it would likely be microbial, at least at first. Simple bacteria-like organisms, feeding on hydrogen, sulfur, or methane. No sunlight, no plants, just pure chemical energy. But here's the twist. On Earth, these simple organisms form the base of entire ecosystems. Tube worms and clams feed on the bacteria. Crabs and fish feed on them. Over millions of years, complex life develops, all in the dark. So, could Europa have something similar? Microbes clinging to vent chimneys? Colonies of strange, alien creatures living in eternal night? We don't know. But if life ever started on Europa, if chemistry turned into biology in that deep ocean, then hydrothermal vents would be the likeliest place for it to thrive. And what's even more compelling is this. If life arose twice, independently, once on Earth, once on Europa, then the universe may be teeming with life. It means life isn't rare. It's inevitable. For decades, the search for life beyond Earth focused on planets like ours, rocky, in the habitable zone, with atmospheres and sunlight. But if Europa has vents, and if those vents can support life, then it turns that model on its head. It means life doesn't need sunlight. It doesn't need a surface at all. It can exist in underground oceans, protected from radiation, warmed by gravitational forces, even on tiny moons, drifting through the cold shadows of gas giants. And that changes everything. It means that Europa isn't unique. Other moons, like Saturn's Enceladus or Neptune's Triton, might have similar oceans and similar vents. Exoplanets in other solar systems, especially icy worlds with tidal forces, may be even more habitable than Earth-like planets. The cosmos becomes not just full of stars and planets, but of hidden oceans. Fortunately, we don't have to just speculate. Help is on the way. NASA's Europa Clipper is scheduled to launch in the early 2030s. It won't land, but it will perform dozens of flybys, scanning the moon with radar, cameras, and magnetometers. Its mission: to map the ice, analyze the plumes, and determine whether Europa's ocean has the right chemistry for life. If we're lucky, it may find signs of hydrothermal activity, perhaps even biosignatures, molecular hints that life exists or once existed in that alien sea. Farther in the future, there are dreams of sending a lander or even a submarine, a probe that could melt through the ice, dive into the ocean, and search for life directly. It's an ambitious vision and one that will take time. But the prize is monumental. Because if we find life on Europa, even in its simplest form, we will have answered one of humanity's oldest questions. Are we alone? We look at Europa through telescopes and spacecraft. We see the ice, the cracks, the silence. But deep below that silence, there may be heat, motion, chemistry, and life, clinging to rocks in the dark, thriving in vents of fire and water, unaware of stars and planets and the beings watching from afar. What if Europa has ocean vents? What if life began there and never stopped?